Welcome back everybody to another video lecture from Mrs. Semino. Tonight we're going to be talking about an introduction to moles, and this is part 1. And so you might be noticing right away that this is kind of crossed out here. If you're in regular chemistry, this PowerPoint is going to follow along nicely with chapter 10. Otherwise, if you are in honors chemistry, this is just that last part of chapter 3 where we're introducing moles into atoms. So I'm taking this first set of slides and dividing it into two parts because it actually is a lot of information for one video. So today what we're going to be doing in this first part is to describe the methods of measuring the amount of something, so that's pretty easy. We're also going to define Avogadro's number as it relates to the mole of a substance. And we're also going to be, it's not mentioned here, we're also going to be making some calculations from moles to representative particles, and also back from representative particles to moles. So that's what's going to be included on this first part of the video. The second part, we're going to distinguish between the atomic mass and describe how the mass of a mole of a compound is calculated. So we're going to be doing like gram formula masses in part 2. Okay, so our first objective was this. How do we measure items? Well, a lot of you guys know that we can measure items in mass, like go get 3 pounds of sweet potatoes. Or we can measure in volume, get 2 gallons of milk. Or we can count in pieces, go buy me 8 bananas. So we kind of use these general terms mass, volume, and we count in pieces. But if we think about the units that we might use with these ways that we measure, mass would be associated with grams, that's a unit for massing things. Volume would be associated with liters. Remember, we are using that metric system there. And then this last one here, counting pieces, in chemistry we use something called moles. Now you might be asking, well, what is a mole? Well, we're not talking about these cute kinds of moles here. A mole, and it's abbreviated MOL, and this is actually a big mistake that kids make, is I know this looks like the first part of the word molecule, so some people think that MOL means molecule. No, it means mole, so please get that right now. So it's defined as an amount defined as the number of carbon atoms in exactly 12 grams of carbon-12. And I know that sounds really fancy, and we're going to explain what that means in a minute. The conversion factor that we're going to need for this is that 1 mole is equal to 6.02 times 10 to the 20, ooh, I hate these things, 23rd of a representative particle. And so let's first look at this. It says a mole is equal to 6.02 times 10 to the 23rd things. Because remember, a mole, we were using a mole in order to count the number of things. So when I say a mole, it's equal to 6.02 times 10 to the 23rd things. So what you want to do is kind of just treat it like a very large dozen. So if I was to send you out to the store for a dozen eggs, you would know just right away probably that a dozen is equal to 12. Also, this number 6.02 times 10 to the 23rd, 23rd people, is called Avogadro's number. So a couple quick things. Mole, defined as the number of carbon atoms in exactly 12 grams of carbon-12. Awesome, it's a factoid. This is important right here. You need this conversion factor that 1 mole is equal to 6.02 times 10 to the 23rd representative particles. And we're going to talk more specifically about, like, well, what's a representative particle? You want to treat it like a very large dozen. I know it seems like a very scary number, but we'll be using the word mole just as commonly as we use the word dozen. And this value, 6.02 times 10 to the 23rd, is called Avogadro's number. So when we talk about a mole, I know it sounds like a weird word to use, but I just wanted to show you that we also use other weird words to mean amounts as well. So if I'm saying a pair of something, it means 2 of them. Obviously, if a dozen, it means 12. A gross you might not have heard before, but as like a teacher, this is what we do, like a lot of pencils. So 144 items is a gross of things. And then a ream of paper, which some of you may have brought in for extra credit, is actually 500 sheets of extra credit, or 500 sheets of paper. I bet you wish it was 500 points of extra credit. But the idea here is we are going to use the word mole, and it's no different. It just means a number. It's just telling you a number, just how these other words are telling you a number of items. So remember I said that you were going to need to pay attention to that conversion factor, 6.02 times 10 to the 23rd representative particles equals 1 mole. And I was like, well, we'll get back to what a representative particle is. So here we are. So what are representative particles? And they're going to be the smallest pieces of a substance. So let's just think about this definition of a substance. Remember, this could have meant a couple of different things. It could have been an element, it could have been a molecule, it could have been a compound. So for a molecule, it's the molecular compound, it's going to be the molecule. For an ionic compound, the smallest form thing is going to be a formula unit. Remember, ions come together with the positive and negative charges. For an element, it's going to be the individual atom. And then also, though, remember those 7 diatomic elements that are listed on the top of your periodic table? Those guys are always going to be like O2 for oxygen, hydrogen is H2, fluorine F2, so on. Okay, so here's where we start to get into the calculations for this unit. So what we're going to do is we're going to go from number of particles to number of moles. So the way that we would do this, the general setup, is you would take your given, or your representative particles, you would apply a conversion factor to get it out of representative particles. So notice the representative particles are on the top, they're on the bottom, so they will cancel. And then we're just going to multiply it by 1 mole. And in case you're like, oh my gosh, where do we get this conversion factor? Remember, we just got this from the last screen, that 1 mole is equal to 6.02 times 10 to the 23rd representative particles. This is really no different than saying like you have 1 foot is equal to 12 inches. So don't forget how to use those conversion factors. So let me go ahead and set up an example here on the bottom. So let's say your problem read something like this. How many moles, and notice we put moles down here because it's asking for how many, so that's going to be in our final answer. So how many moles are in 2.98 times 10 to the 12th atoms? So the way that we would set up that conversion factor is just the same way in our example. We would put the 1 mole on the top. We would put the 6.02 times 10 to the 23rd atoms on the bottom. Those atoms are going to cancel. And then when we do the math on this, it comes out to be 4.95, and not quite there yet. Let me figure out my decimals here. I got to count over my zeros. Give me a second. And it looks like it was over about 12 spots. So our final answer here is that 2.98 times 10 to the 12th atoms is equal to 4.95 times 10 to the negative 12th moles. Now look here, I just want to remind you guys about significant figures. So the way that we base significant figures off in my class is your final answer wants to have as many significant figures as your given did. So in this case our given had 2.98, so that's 3 sig figs, so your final answer needs to also have 3 sig figs. Now we just a second ago went from particles to moles. Now here we're going to go from moles to the number of particles. So we set this up really similarly. You take your given, you set that up front, you add your conversion factor, and then it's going to get you into the units that you're looking for. So this time we're starting with moles, so that's our given. We're just going to simply flip this conversion factor here. We just flip the conversion factor because we want to get into representative particles. These moles will end up canceling, left in representative particles. So it says here, remember, even though you may know the number of representative particles, you may not know the numbers of atoms in the sample. So it's kind of reminding you that, for example, carbon dioxide here has 3 atoms, so if the problem was asking how many atoms, you would need to multiply the representative particles by 3. So there's a few example problems in your textbook that you could do. So let me give you a quick example problem here on the bottom. So for this problem, let's say you were given 1.5 moles of oxygen gas, and again, notice O2, so it's diatomic, and it says you have 1.5 moles of oxygen. How many atoms do you have? So the way that we would solve this problem is we would need to convert from moles into molecules, which is another way of saying representative particles, and then we would need to take this number and multiply it by 2, because if it's asking for atoms, in each one of these representative particles there's 2 atoms. So let's go ahead and set this up. So we have our given 1.5 moles of oxygen. We're going to take our 6.02 times 10 to the 23rd molecules. I'm kind of like writing way over, and then over 1 mole. Okay, and then of course our moles are going to cancel out, and so then when I do this math here, 1.5 times 6.02 times 10 to the 23rd, I come out with a value of 9.03 times 10 to the 23rd. And so remember, we're not done yet, because in this imaginary sample problem, we were asking for the number of atoms. So I would need to then take this value and I would need to multiply it by 2. So when I do that, times 2, let's hope this works. Okay, awesome. I come out with a value of 1.8 times 10 to the 24th atoms. So a couple of things besides the answer, lovely answer came out, but a couple of things to our answer that I want to point out is notice how many significant figures I have here. Our given only had 2 significant figures, so our final answer can only have 2 significant figures. And then remember, in chemistry it's super important. Answer has to have 2 things. It has to have its numeric value, which it does, but then it also needs its units. So in this case, it's atoms. Let me add this. It's atoms. So your answer needs to have the numeric value and the units value. So folks, this is where I'm going to leave you for the end of part 1. Remember that in part 2 of this first section, we're going to be talking about how to find the molar mass, which is also referred to as the gram formula mass. And then in the second section, we're going to be talking about how to do more different types of mole conversions. I hope this helped introduce the mole, as well as show you how to make these calculations from representative particles to moles and from moles to representative particles.